Hello! Contained within this cardboard box is all of the things you need to turn your diesel heater, whether it be the cheap Chinese one, a planar, a Everspacher, a Webasto, turn that into something that makes hot water as well as hot air. Right, what is in the box? Thankfully, there are handy instructions that tell you what is in the box. Bits of paper, they're not on the list. A vented tank, if you've ordered a vented tank, or if you've got your own tank, you probably won't have a tank, or a water tank. So, tank, there's an O-ring, there's a vented cap with the vent on it, it's actually vented. Vented tank, 2 tank connectors. Wait, there's things in the tank. Kommen Sie out, bitte. This is like a game, you have to try and get the things out of the tank. That's some stuck. Ah! Right, as long as my hand doesn't. Oh, Jesus. Right. 1 tank, now empty. Hello? Empty tank. What I have here is 2 temperature controller thermistor sensitive things. I have the circulation pump, that's the word I was looking for. A roll of PTFE tape which has gone back inside the tank. Frog snacks. There. Okay. 1 PTFE, poly tetrafluoroethylene. Anyone? Was I even close? Was I even close? 1.5 meters of silicon hose. It's silicon hose. Not the reinforced kind, because, well, we're not running at pressure here, we're just running hot water. Well, warm water. Warm, hot. What else? Here are the adapters you'll require to attach your heater. Well, not attach. Yeah, attach the end of your heater to the heat exchangers, and the heat exchangers to the output. I put somewhere where I don't drop them on the floor. Right, that's that bit. There's the O-ring and the lid of the tank again. Will you go down there? That just leaves 2 heat exchangers and an empty box. Goodbye. This is the large heat exchanger. 1 large heat exchanger. No, there's things in the box. There are all sorts of screws, barbed fittings, and different barbed fittings, and more different barbed fittings in that box, and in the small box there is another smaller heat exchanger, and nothing else in the box. So that's all the bits. Now let us assemble it. Oh, I should have read the instructions before I started. You know what's missing? We're missing a diesel heater. That's usually gonna need. That's fine, the end's missing anyway. That's ideal. And yes, I'm going to run it on its side. Because I can. Because the glow plug is at the top, which means the hole for the burn chamber is also at the top, so it doesn't fill up with diesel. So we're good to go in that sense. I can run it on its side and we'll just get slightly poisoned with carbon monoxide, but that's okay because we're inside by ourselves and I accept full responsibility. Right, in this I will show you assembling it with the heater here and not all plumbed in, and I'll plumb the heater in myself and then we'll see it running, or we'll already have seen it running because I'm going to edit the video in that direction. But let's set it up. What else we need? 10 and 5mm drill bit, pliers, small screwdriver, spanners, and screws to screw things, and some Sikaflex. Okay. I will go and fetch all those things. Right, I have my, 10 and a 5mm drill bit, a drill, and we need to drill and deburr 2 10mm holes for the water inlet and the water outlet. a 5mm hole on the top for the thermocouple, and the other outlet is the outlet to your appliance, so that it'd be your sink pump or whatever, shower pump or whatever. I'm not going to drill this hole at the moment, as I do not require the third hole, because we're just going to see it heating up. I don't need to run a sink or a shower with it. That's for yourselves to decide what you're going to plumb it into. So I'm going to assume these are the fittings for the hot in and hot out. Ooh, these are nice. They are nice. Oh. It's a double O-ringed screw-in fitting, and then that screws. Oh, that's going to need some PTFE tape. That's for sure. That's fine. Let me just check these are the 10mm ones. Yes, they're the 10mm ones. Right. So 2 10mm holes. What does it say? Need to keep them off the bottom of the tank by, well, that much obviously, because you need to be able to get the nut onto the bottom of the tank. And if you do it right at the bottom, you won't be able to screw it in place. So let's get drilling. So I'm just going to do mine at opposite corners of the tank. And that way you get the best circulation of water around the inside of your tank for, you know, what's the word? Turbulence and mixing up and disturbing it. Right, let's... one of them. 2 10mm holes somewhere near, well, that's quite a thick bottom, isn't it? Yes, it's got a thick bottom. Yeah, aye, and it's also got a curve, so I would bring it up a little bit, and in the corner, and somewhere about there. 1 tank. I'll deburr that in a minute. Right, 1 there, 1 in, 1 out. Nearly escaped. Oh, that one's a really nice drill. It's made a nice hole. Right, where is my cone cutter? Cone cutting / deburring tool. I just do it by hand. Will that work? Yeah, just take the edge off it. That'll do it. I'll deburr it just nicely. See what the inside's like. Right, that take one of them. My O-ring's now fallen off. Like that. Poke it through the hole. Idiot. Poke that through the hole. Oh, it's so tight you have to screw the thing in. That's a nice... Okay, so we want that much in there. Take the other one. O-ring side obviously facing the other O-ring. And then screw that one on the inside. And then get in there. Well, let me just undo that a little bit. Perhaps I should PTFE tape this just now before I get too carried away. Yeah. That might have been a wise move. Let me PTFE this first. I'll do. I'm spinning here. Ah, no. O-ring's falling off again. Screw that in. And then find the appropriate size spanner. 12 or 13? Is that 13? Is it a 13? Nope, that's a 15. 13, 14. 15? Is it a 15? It is a 15 15mm spanner, and I'm going to do the inside one as well because I can get a spanner in, and we'll just you know what I should have got is a ratchet spanner. That would have been a much better idea, David. Why didn't you get a ratchet spanner? If you have ratchet spanners, always use ratchet spanners. Right, now I need to, yeah. Just tighten this one up as well. Now remember, they just need to be snug. You just want to not leak. You're not looking for, you're not building a bridge here. You just want it to be tight, but not, insanely tight. Okay, repeat for the other hole. Once your barbs are affixed, obviously you'll have another hole somewhere for your output to your sink or shower or whatever it is you're going to output to. I'm just going to have it open because that's all we need. Go and wash your tank out and make sure you got all the plastic out the inside, because you don't want to be running that through your pumps and get them stuck in the heat exchangers, etc. I'll go and give that a wash out outside, and then we'll come back and put the heat exchangers together and put them onto the heater. Nearly forgot, 5mm hole in the top to poke the thermocoupling. I'm just going to do mine right there. And then go and clean the inside the tank again. You got the plastic back out. Such is life. Next up, get your 2 heat exchangers and these beautiful little black chrome barbs, which are O-ringed, so we don't need to PTFE these tape. Well, you can PTFE tape these if you really want for extra leak resistance, but you shouldn't need to if they're O-ringed. So we will screw these into here. Will they be the same 15mm spanner? Why? Why? No. They are. They look the 16s. Okay. It's not a problem, honest. It's not an issue. I've got 16mm spanner right here. Ooh, nearly fell. 16s, yes. So we'll just tighten these up gently. Again, not super tight. You just have to snug them up. Basically till the O-ring gets squashed enough. It's probably a Torx spec. You could look it up, but I could invent one for you. Some torque. 3 Torx. 3, maybe 4 torque. Torque is a measurement of how loud you grunt when you're tightening something up. Like 3 Torx is like a little bit. Like 120 Torx that's a lot. You make a scream like a wild animal. Right, they are tight enough for me. Tight as a tiger. Okay, so 2 heat exchangers with the barbs attached to the ends. So we've got heat exchangers. Let me just tidy up some of this a little bit. Next is, there's a bag of screws somewhere. Bag of screws. I'm going to require a screwdriver also. Oh, will this screwdriver be appropriate? Screwdrivers. And appropriate quantity of screws. Is this screwdriver a good fit? Yes, good. Okay, this is where we take the 3D printed parts and attach them to these parts. So this is the outlet, the smallest end. We'll call it the smallest end. We just want to screw them onto the screw holes. They're there somewhere. Now don't go super, heavy-handed on this, because you are screwing down a 3D printed part. Granted, it's fairly strong, but you don't have to go super crazy doing this tightness. Just get them all started, and then you can go back and snug them up. And don't cross-thread them like I'm trying to do right now. So far, so good. So far, so good. Cross-threading will introduce problems. Like, cross-threading is its own problem. Right, snug that down. If you hear your 3D print crack, you've snugged it down too much. I'm going to change screw. I don't like the size of the head in this one. I need a slightly larger head. Slightly larger. How about this one? That looks more appropriately sized. Oh yes, that's much better. What a difference. One end attached. Then we'll attach the other end. Yes. Put that one in there, that one, and that, and then screw this one on the inside. Because if you put the big one on first, you can't get inside to screw the little one on. Ask me how I know. They could actually do with a little drill just to clean up the print. What size have we got? 5's too small. Let's swap it for a 6. This is just cleaning the hole out, folks. It's just giving it a... There's just a little bit of 3D print residue left in there. I'll just... It's kind of like deburring what I'm doing. Just giving it a little deburr. Just get the screw back out now. Come out. There. Everyone's trying to escape at the moment. Right. I'll deburr that just a little bit. That should be better now. I should have also pointed out that you want the barbs at the top, like these stands at the bottom. I mean, so it's sitting like that. And now we'll put the big heat exchanger onto the little setup. Do that in there. We'll get the screws into that. Also, try not to poke your screwdriver through the fins of the heat exchangers, because that'll ruin your day really quickly, honestly. It really will. It really, really will. That wasn't a cracking, that was just me leaning on the table. Honest, haven't broken anything. Not yet, anyway. Right, that's those two, and then we'll do the input vent adapter, heater adapter thing. You know what I mean. And it goes on there, that's last. And I've got the right number of screws left, which is always a bonus. Again, not too much. It's just 3D print. This bit looks fairly solid. This bit looks fairly solidly printed for screwing into. Not screwing into, screwing down onto to snug it up. Okay, and that leaves you with the heat exchanger assembly. That's fucking awesome. Excuse my French. That is fantastic. The beauty of it for me is the actual simplicity of it. It's two off-the-shelf heat exchangers with custom designed and 3D printed. Oh, I love 3D printed parts. Into this, and that's it. You just put that on the end of your heater, and you know, once you've plumbed it in, you've hot water or hot air, depending on how you use it. Ah, it's beautiful. It is fantastic. I did have this thought a while ago, but I never bothered to do anything with it because I've got an old computer, you know, water cooling radiator. I thought I could get a 3D print a thing to fit that radiator in there and do exactly this, but this is so much nicer. It is so much nicer than, well, I'm not the best in SolidWorks, let's just say that. This is fantastic. I mean, of course, could you make this yourself? Absolutely. Would it be worth the effort versus just paying the money? Probably not. So, now we've got that much done. We have built up the, this assembly, the heat exchanger assembly. It's a matter of plumbing in the water from your tank, to and from your tank, and the heat exchangers and the circulation pump. And then after that it is a bit of wiring. Okay, right. Let's get plumbing. Let's set all this up so it'll actually work, and then we'll learn about plumbing. Okay, we are going to plumb, the pipe between the heat exchangers, the pump, and the tank. And I just rattled the tripod there. I apologise. So we're going to go. Stop doing that. Tank into one of these. It doesn't matter what. Just pick one. And then you run the next one up to the next size of heat exchanger, and then the biggest heat exchanger back to tank. So for the time, we just want to make a loop at the moment of. You don't want to kink your, because you can obviously, there's only so little radius you can go before it kinks over. So a good size of pipe, so you don't get kinks. You don't want to kink. So I'm going to go for about there, and then using a proper pipe cutting device, a mostly blunt Stanley knife will be fine for me. There we go. Cut bit of pipe. So that's a bit of pipe. And as per the instructions, it says you do not need a hose clip onto these barbed fittings. That's because they're sharp and they grip the pipe really well. So squeeze that one over there. Oh, yeah, beautiful. And give that one a nice radii bend. Attach that one to that one. I think I should have done it the other way. It would have been close to the tank. Not to worry. Also, the pipe clips, there are two sizes. The large ones are for the tank and the small ones are for the pump. And this is look, it's the teeniest, tiniest, cutest little pump you've ever seen. Look at the size. Oh, it's like a baby pump. Maybe it'll grow up into a real pump when it's bigger. I just want to pump things. Right. Sorry, I got carried away there. So excited. Right, we've got a little pump here. And we will need a bit of pipe that goes from, well, I've got this much pipe left. Right, can you even see this much? What I'm going to do is just cut it in half. And that'll be, no, don't cut it in half. Yes, cut it in, oh, I might have to, Right, we're going a bit from here to there. So that leaves me that much. Okay, that'll do for that bit. And then, is that about half, David? Pretty much in half. We're just going to cut the pipe in half. Yeah, if I need more pipe, I will go and find more pipe in my collection of pipes. Honest. I will make it work. Here I am cutting this bit. Yeah, solid. Right, that's one of these on the end. On the end. It goes and now finds a pair of pliers. A pair of pliers to squeeze said pipe clip a little bit so it fits over the end of the pipe. And then we'll attach this to the tank. I know you can't see me attach to the tank, but honestly, I am just pushing it over the barb on the tank. And then taking my pliers, and then I'm just going to move the pipe clip up a little bit. Up a little bit. Like that. That's on there. Take that. Squeeze it on the end here. And then that just leaves me a bit of pipe to go from the pump to the tank, which I might have to get a little bit creative here. Oh, I'll say that. I could just put the pump in between the two. I might just have to set it on something. Because I only need a little bit to go from the... right, it's in that bit and out that bit. That's the pump direction. Well, it usually is, yes. In the front, out the top. I could have done with slightly more, or slightly less tank height. That would have been a start. Okay. We're making it work. We're making it work. Obviously, the amount of pipe in your kit is, well, it's up to you where you put your, like, your tank might be further away or closer or any of the little clampy thing. Little clampy thing. Slightly bigger clampy thing. Over the end of the pipe. Come on. WD-40 is good for lubrication if your things are too tight. So I'll put that on there. Output of the pump. I see why it has a spring clip for the pump, as the pump is a slightly different, slightly smaller barb size than the everything else. It's not just as good a fit, so hence the spring clips will take care of that problem. Go on, down a bit. Oh, I oughta. Right, that attached. That is attached. So we'll take that and we'll poke it. Poke it in there. Honest. Poke it. Poke it in there. Right. So we've got that. You know what, we'll just rotate it. And then we'll go another pipe clip on each one. One on each end because we're going to the tank again this time. So one on this end. Okay, so it's not ideal. I could have done with a bit more hose, but that's because I'm building this on a bench and not in where it's supposed to be. I could just slide that off a bit. Hold on. Oh God, it's got worse. Everything just got worse. There, that's better. There we go. Fine now. Perfect. It's close enough to perfect as it'll matter. Right, can you even see this monstrosity what I have created? Tank, 2 fittings plumbed through the pump. Your pump, of course, would be attached to the floor, or, you know, the base of wherever it is you're building your installation. Installation, that's the word. Pump out into first heat exchanger loops into the bigger heat exchanger, and the biggest heat exchanger then loops back up into the tank. In your tank, you would have another hole to go to your other pump, or your, you know, for your shower, or for your sink, or whatever. Hell, you could even put this up high, longer hoses, and then just have a gravity feed down to a tap. And that would do. As you can see here, it is sort of not attached to anything. What you would have is your heater in place, obviously it'd be the right way up, bolted into the floor. Then you would slide this up to meet your heater, and then you would obviously attach this to the floor as well, and that does the thing. Now, do I have a bit of ducting, or did I throw it all far away? And then you would have a piece of ducting poked in the end here. He said, poking it in the end. If there wasn't so many things in the way on my bench. Right. A bit of ducting in there. And then that ducts more out. God, can you even see it? Everything's black in this picture. Why is that? Right. You poke your ducting in the end there, and then your ducting goes somewhere. So I might unkink. Well, yeah, I'm definitely going to have to make that a length and not poke it into the bin bag, as that will not allow appropriate airflow. Okay. Next, electronics. Everyone's favourite. Oh, look, so many wires and such complexity. It's not. Most of these are all attached to each other. We've only got some ground, some 12-volt positives, and a wire to join those other bits together. Okay. Open your packets. 2 packets. Put the rest in the bin. Do we need the Chinese instructions? No, because they're in Chinese. Are they in Chinese and English, or are they just in Chinese? There are some English versions. Okay, that's... If we get stuck, we'll come back to that. Right, these are not high load devices, so we have one. One is for the water temperature controller, and one is the air temperature controller, because it only switches on once the air is hot enough to start, you know, heating the water up. Does that make sense? Right. And obviously you've got a thermistor attached to your water controller. Okay. Okay, one of them, well, 2 of them technically, right. I'm going to need to find some wire. Should have brought the electronics box in with me. Well, you didn't, dumbass, so I need to go and find a bit of 2-core speaker wire type wire, because that'll be heavy enough. Right, we are totally doing this live. I don't mean electricity live, I mean I'm going to read the instructions and do the thing at the same time. Right, give me a marker pen. So, we want one for air. I'm going to put an A on it for air. A for air. And W for water. Air and water, as per the instructions. Which, if I can manage to put them on screen just now, I'll put them on screen. So, we need one length of wire that's going to be, well, the main length of wire we're going to put into things. So we need enough to go to a power supply, which is going to be somewhere nearby. Is it going to be there? Right, over here somewhere. So we'll need this much wire. This much wire. We'll start with this bit. This would be easier if this was on the bench. Length of wire, please sit there. I've lost the end now. Oh, I just, there it is. Jeez, sat the end down. Don't do that. Right. So we need a positive and a ground. We also need another positive as a splicing wire. Right, let's just start with, so we'll just get another bit of wire, because we need a bit of wire that's going to join the 2 together. So we don't need much wire. Let's cut a few bits of that, just so we've got some usable colours. Well, I see we've only got 2 colours. And yes, there are 3 colours in the diagram. I can't find any other colour wire. I was sure I had a green bit, but cannot find it, so we will not use it. There's a red bit, and a black bit, and a red bit, and a black bit. And I need a small screwdriver to screw the screws. Do I have such a screwdriver? Ugh. Yes. Perhaps even that one. There's a... So, this will be our wire coming from our power supply. And onto that, we need to splice another positive. Okay, let's just snip a bit of that. Take another positive. Strip the end of that. I might be stripping too much end, but that's okay. That's okay. Bit of that. Snapping at that one. Yep. Twist that. Twist these two together. Remember, this is only low current running a small pump. It's not mains voltage, it's not glow plugs, it's not anything like that. So our first wire comes into S1 and VCC. S1 and VCC. So let's open them up. VCC, S1. We'll poke the two that are joined together. I have to open that up a bit more. And then jam that in there. Now, what I should have done is just soldered these and then snipped them, and then it would have given me a nice solid, not connection, but you know, a solid piece that I could push into the hole. That would have worked as well. That would work a lot better. Oh, I am butchering the end of this. Please forgive me. Right, actual snips. There. It's going fine. It's going fine. Right, push that in S1. S1. And then tighten it down. 4 empty noses. S1. That is a terrible screw head. I'm going back to using the flat piece. Oh, that's better. Right, and then we take the other one and we put it into VCC. And that gets us a bridge into here. I managed to not twist that all the way to the end. Even though it is real copper wire. Right. And then next time I know not to cut the ends off so much, as we do not need as much. Right, that just leaves the ground wire that goes out to the supply. Twist that. Put that into the ground hole, which you have not opened. Undo that. And put that in the ground. Like that. Now, if you're going to attach this directly to a battery, I would absolutely have a fuse. A fuse on. Sorry, I was going to say it doesn't matter. It does matter. It really does. A fuse on the positive side of this wire. I'm even in shop, but a fuse on here. You know you get them. You can put these two bits of wire in and get a blade fuse, a blade fuse, and that gives you a nice fused bit, and then attach that to your battery or your power supply or whatever, and that will make it nice and safe. In case you fuck this up like I'm probably about to do, and things will go bang. No, the fuse will go bang, as opposed to your expensive leisure cell batteries going bang, because you do not want that. That would be a sad, sad day. Right, I'm just going to set those two wires over there just now. They are my main power supply wires. Yes. Although I needed to splice another ground into that, because I need to go ground to ground, and then ground to the pump. I could just screw the pump into the same ground. Oh look, it's raining again. Who would have guessed it? And it's to be 28 degrees tomorrow. Just now, it's cold and it's wet. I'll just snip the end of this connector off. Strip some of this back. Gently does it. Gently, there we go. Right, that gives us a nice red and black wire for the pump, which I could actually feed that underneath. That would be That'll be much better. So I should have made a jumper ground wire between the ground on this one, the ground on this one, and the pump. We can do that right now. Snip a little bit of that. And a little bit of that. And at the end we'll go back and we'll put the other wire that should be a different colour in, and we'll use a bit of wire. And it'll look really confusing because there'll be red and black and then this random red wire probably. So that's going into this ground, which I should have twisted to this ground. So let's take this one back out. I'm really wishing that I'd soldered some of them together now. But hey, here we are, still doing my best. Right, so we've now got a ground loop. And poke that in the ground hole. Not poking anything in the ground hole because it's not long enough. Oh. Every few minutes I regret not getting the soldering iron out and just doing this properly. Every few minutes. Loud sigh. Please, if you're doing this, please just get the soldering iron out, solder the wires together, and then chop them, and then just poke them in the hole. It'll go so much nicer. Instead of trying to twist and stab and poke and cut. Honestly, right, this time. Come on. Nah, I'm gonna get angry in a moment. Let's rage building. Not being able to see the holes also part of my problem. Okay, this time it's in. Stay. Get in the hole, please. Okay, we have two grounds. They're not touching anything else. Right, okay, we've got a ground out to that ground, and then we'll attach the pump to that ground as well. And that's all the grounds grounded. Wow, I'm not sure my strippers are going to be able to strip. This is so thin. Oh, I lied. Go gently and it works. Okay, take that one, twist that around here, solder it properly. Please do. Please solder. Don't be me. Don't be me. Do a job properly. Ah, forgot to open it up again. Okay. That goes in the ground. Screw it down. Dun, 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 dun. Okay. Ground. And then we need the positive from the pump into switch 2. Let's see if I can gently open this one as well. Yes, success. I'll give this one a twist and a fold. This is very I was going to say very small. It's also very thin. Very small, very thin. Into S2. Who thought that the longest part of this project would be screwing these wires together? Who would have guessed it? Who would have guessed it? Get in the hole, please. Okay. The pump is in there. Right, that's the positive and the negative bit done. Now we just have to connect PCC, S1 and S2 on this. So have I got enough wires to this? S1 to S2 and then that to that. Yes, we can make this work and not have any wire left over. Well, that was good. It was. And I need a longer bit on this end for twisting. And same on this one. And what one out? No, gonna sneeze there. It's not coronavirus, honest. It's just a sneeze. It's just a sneeze, people. Just a sneeze. Please. Please, please. Right, twist these two together. Right, where'd these go? He's got an S1. Yes. Oh, I'm not even chopping them down anymore. I'm just going to push it in. Just going to push it straight in. Maybe. I really don't. These aren't the nicest. Push it real good. Once again, I'd like to advocate soldering these connections properly and making a proper connection on the end. Possibly even making a terminal, perhaps, and get someone that knows what they're doing when you're doing this bit. Not me. I can't even get the screwdriver to work at the moment. Okay, that one and that one, and then we'll take this one. In here. And jam that in there. Where's the other end going? Oh, really? And then that goes into S2 at the end. Because one of them turns the other one on, which makes sense, I suppose. Right. That one goes in there. Right, water, air, all wired as per the instructions, hopefully. Let me just strip these ends. Oh, helps if he doesn't lean on that bit. So, that's the air, that's the water. So left is now the air. There's my marker pen. So, we'll make that one the air. And that one's the water. Right, so it does work. Let me just set it to 12 volts. Okay, power supply is at 12 volts. Quick, can you see them? Is that on? Can you see the? It is on. 14.7. I presume that's the temperature, not the voltage, because that doesn't make any sense. Well, here we go. Where is the sensor? 14.7. So I put it in my hand. There you go. You see her climbing, skyrocketing up there. Yes. Okay. So that's the air temperature sensor. Now, where does the air temperature sensor get poked? Blah, 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 rear move, screw them on the wall, I'm not doing that one. Aye, this one goes into the fitting closest to the heater, which, okay, that would have been, right, I have to zoom out for this bit, yeah. Wow, it's over here. So on the back of the 3D printed part that goes into the heater, if I just slide my heater out of the way a minute, there is a fitting printed into the 3D part into which you can push what? It's too big. It no fit. I want that to go in that. I presume it goes in that hole. That's where I would have put it. Slide into the fitting. That doesn't slide. There is no sliding in that system whatsoever. Still filming this bit? Yeah, right. Okay. Yeah. So it says slide into this fitting, but it doesn't quite slide in. I'm just going to give it a little. Okay, that's better. That'll be much better. Now we can poke it in. Ah, look at that. It just needed a little touch with the drill. A little touch. There we go. Right, that's now in there. That can go there and move all these things out of the way and put the heater back in place. It's still heavy, it's not going to later. Right, okay. So that gives us that. And then the other probe, which is this one, goes in the water tank. Okay. Again, the bench setup, you'll see the sensors are here so that we can see them, and my bit of wire doesn't quite make it up and into the tank and at the bottom. So what we're going to do is cheat. We'll just tape it onto the outside of the box just now. Bit of tape. We'll just tape it right there. Right there. Because once this is full of water, it'll be as close to the dammit on the outside temperature as it is on the inside. It'll also give us a nice black spot to point the flare at as well. So, what have we got so far? Zoom out. Main heater body, which would be properly assembled into your van, etc, etc. We have the 3D printed part that goes into the large heat exchanger, then another 3D printed part that goes into the small heat exchanger, and then the small heat exchanger has another 3D printed part which has got your output venting on. Okay, I set the temperature of this to a much lower temperature so it puts the output on and brings on the next one. But we have had a slight technical hitch into which that, let me see if I can put it. So it's set on 60 degrees at the moment. So what I've managed to do is set it, and I think the controller has died because I can no longer adjust anything on it. Because there's a step in this that we have to do, which is to go into the settings, which is press and hold set, and you can see that says P0 now. And we're changing that C to an H, but I can't because the up and down buttons work, but I press set again and I'm supposed to be able to change that. It works in the other controller, it works in this one, like if I go in here, press and hold set, and press set again, see that flashes? I can change it to a C or an H, and press set again, and then it sets and then just leave it alone and it goes back. This one has died. This one has passed away. I can press and hold set, press set, nothing happens. Up and down buttons work, but they don't. So I think this controller has died. So in order to finish the video, what I'm going to do is swap this one out for the SDC 1000 that I was using with the other heater. This is the 12 volt version. We'll just wire it in the same way and poke its probe where we're going to poke it. Because all you want this controller is doing is turning off when it gets to this set temperature. You want the pump to be running all the time this is on, and then turn off once you get to your set temperature. And then it stops heating the water up because the water is no longer flowing through it, so it no longer heats up. So I'm going to unwire this one, wire this one back in, we'll set it to 55 degrees, and we'll, if this is long enough, we'll poke it in the tank. If it's not long enough, we'll just sellotape it to the side again. Right, I'm going to do that. Okay, we are set to back up again with the SDC 1000 and the original controller. So let's just pretend that the air has come up to temperature, so we'll drop that. That tells this to come on, and the pump is running just now. You probably won't be able to hear it, but I guarantee it is running. So it runs just now, and then I've set this to 55 degrees. One of these tells me what I've set it to. 55. So I've set it to 55. So when the water temperature gets up to 55, this will turn off. And that cuts the pump running and stops the hot water being produced. So I'm just going to let that sit to that there, and now we can fire it all up and watch it do its thing.